In this video, I will explain how to find the final velocity in a projectile motion problem in physics. So let's jump right into an example. This says, a man stands on top of a tower and kicks a ball at a 30-degree angle with an initial velocity of 10 meters per second. It takes 8 seconds for the ball to hit the ground. Find the final velocity of the ball just before it hits the ground. So I've gone ahead and sketched out this situation. We have this man on top of this tower. He's kicking this ball with an initial velocity of 10 meters per second at an angle of 30 degrees. And we want to know what's the final velocity, let's call it v sub f, right here, just before it hits the ground. So the way that we're going to figure this out is we're going to recognize that the final velocity is just going to be a vector. So the ball is going to be hitting the ground, and what we can do to actually figure out what this final velocity is we can break this vector into two components, the y component, so let's call that the final velocity in the y direction, along with the x component. So let's call that the final velocity in the x direction. So if we can just find these two components, it becomes very easy to find this final velocity. So let's start by finding the final velocity in the x direction. So what we need to know to figure that out is that when this ball is kicked, the whole time that it's headed in the x direction, the velocity in the x direction will be constant. Now, the velocity in the y direction will be changing due to gravity, but the x direction is going to be constant the whole time. So actually all we have to do is just find the initial velocity in the x direction, because that will be equal to the final velocity. So the initial velocity, let's write that down. Let's say v sub 0, the initial velocity in the x direction, that's simply going to be equal to the velocity, which is 10, times the cosine of the angle that the ball was kicked at. So the cosine of 30 degrees. So if you punch this into a calculator, and keep in mind, your calculator should be in degree mode when you're doing the cosine of 30 degrees. It comes out to about 8.66. So that's the initial velocity in the x direction, which is also equal to the final velocity in the x direction. So this is also 8.66. Now we just need to find the final velocity in the y direction. So here's the formula we used to find that. The final velocity in the y direction, that's equal to the initial velocity in the y direction plus acceleration times time. Where acceleration, that's the acceleration of gravity acting on the ball, which is negative 9.8. That would be meters per second squared. And the time, so the time that it takes for the ball to actually hit the ground, we're told, is 8 seconds. So we also know this value. The only value we don't know is the initial velocity in the y direction. So to find that, here's the formula we use. The initial velocity in the y direction, that's equal to the initial velocity of 10. But instead of multiplying it by the cosine of 30, we multiply by the sine of 30 degrees. Now, the sine of 30 degrees, that's actually just 1/2. So this is 10 times 1/2, which is 5. So the initial velocity in the y direction is 5. So now we have everything we need to figure out what this final velocity in the y direction is. So let's write that down. We'll say the final velocity in the y direction is equal to the initial velocity, we just found that's 5, plus acceleration is negative 9.8, and the total time, again, is 8 seconds. So when you punch this into a calculator, you find that the final velocity in the y direction is equal to, that's negative 73.4. So this value right here, the final velocity in the y direction is negative 73.4. So we figured out the y and the x component of the final velocity vector. So here's the formula we can use to actually figure out what this final velocity is. We say the final velocity, v sub f, that's equal to the square root of the final velocity in the y direction squared, plus the final velocity in the x direction squared. So we get the square root of, that's negative 73.4 squared, plus 8.66 squared. So when you punch this into a calculator, it comes out to about 73.91. And we're talking about velocity, so we'll say meters per second. So that's the final velocity of the ball just before it hits the ground. Now, you might also want to know, what is this angle that it actually hits the ground at right here relative to the horizontal? So this angle right here is going to be the same as this angle. And to find this angle, all you have to do is take the inverse tangent of the y component divided by the x component. So the final angle, let's write that down. The angle is just equal to the inverse tangent of the y component is negative 73.4. And when we're doing the inverse tangent, you can just use the positive version of both components. So we'll say positive 73.4 divided by The x component is 8.66. So when you punch this into a calculator, it comes out to about 83.27 degrees. So that's the angle right here. So that's the angle relative to the horizontal. So let's specify that. Let's say below the horizontal. So that's the final angle of the ball right here. So that is how you can solve that type of problem.